Good day, Engineer Cuenca and classmates. We are the Section 6 advocates, and today we are going to talk about the classification of aircraft propellers. So, there are two ways propellers can be classified, and the first classification is according to its position on the aircraft. So, under this category, we have the tractor propellers and the pusher propellers. So tractor propellers are the ones that are mounted on the front of an engine, and this type of propeller puts an aircraft through the air. Now, most aircraft are equipped with the tractor type propeller, and one of the reasons is because lower stresses are induced in the propeller as it rotates in relatively undisturbed air. And another reason for this is because the rocks, gravel, and small objects that are dislodged by the wheels are frequently thrown or drawn into the other type of propeller, which is the pusher type propeller. So, in contrast to tractor propellers, a pusher type propeller are ones that are mounted on the aft end of an aircraft, and they push an airplane through the air. So examples of aircraft that are equipped with this type of propeller are amphibious aircraft because it would be very difficult to install a tractor type propeller on these specific types of aircraft. So now we move on to the second classification of aircraft propeller, which is according to their method of changing pitch. So the propeller types according to this classification are fixed pitch propellers, test club propellers, ground adjustable propellers, reversible pitch propellers, controllable pitch propellers, constant speed propellers, and featherable propellers. So the first propeller that we have is the fixed pitch propeller. A fixed pitch propeller is the simplest of propeller designs, and it is associated with many light piston engine aircraft. So for this type of propeller, its blade pitch or blade angle of attack is built into the propeller, and it cannot be changed after the propeller is built. So because of this, a blade angle is a compromise between the optimum pitch for takeoff, climb, and cruise. So it is important to know that a fixed pitch propeller is just one piece, as you can see here in the picture, and since there's only one pitch setting, the whole configuration is usually a two-blade propeller. So this type of propellers are also generally made of aluminum alloy and wood. So relating to what I said earlier about how this propeller is a compromise, a fixed pitch propeller is designed for a particular aircraft, mostly the smaller ones, to produce optimum efficiency at a specific rotational and forward speed. They are also designed to fit a set of conditions of both airplane and engine speeds, and that any change in these conditions reduces the efficiency of both the propeller and the engine. So lastly, we have the advantages to these types of propellers. So the advantages are that they are less expensive, they are also a simple operation, and aside from that, they do not require any control input from the pilot in flight. Next, we have the test club propellers. So these devices resemble a propeller, and they are designed to be used on an aircraft to test and break in reciprocating engines. These devices are mounted on an engine shaft to absorb engine power, and they are also specifically made to provide the correct amount of load on the engine during the test break-in period. Lastly, it has a multi-blade design which provides extra cooling airflow during the testing period.
Now for the continuation of the report, my name is Lawrence Brandowi Palakpak, and this is the ground adjustable propeller. The ground adjustable propeller operates as fixed pitch propeller. The pitch or the blade angle can be changed only when the propeller is not turning. This is done by loosening the clamping mechanism that holds the blade in place. After the clamping mechanism has been tightened, the pitch of the blades cannot be changed in flight to meet the variable flight requirements. The ground adjustable propeller is not often used on the present day airplanes. So why is it not used in on the present day, because first of all there's a lot of disadvantage. The first one is it can only be adjusted on the ground as mentioned and by its name. Two is it the design is very old. Three is that after you set a certain degree or the pitch, it cannot be adjusted mid-flight. And now to continue our report, we have the reverse pitch propeller. Controllable propellers. It is a controllable propellers that can be changed into negative blade angles during flight are known as the reverse pitch propeller. A reversible pitch is designed to produce thrust in the opposite direction by lowering the blade angle. The engine power increases negative thrust when the propeller blades advance into the negative angle. This will slow down the aircraft and also reduces its ground roll. After touchdown, the aircraft speed is promptly reduced by reversing the propellers, reducing the brake wears. So, as we all know, uh, a reverse pitch propeller is normally found in military aircrafts. You know, the ones that can transport troops from place to place. So the only explanation for the reverse pitch propeller is that it can turn into a negative angle, therefore reversing the whole um, pitch of the blades. Therefore, once reversed, the thrust also reverses. Therefore, the direction matters because, as we all know, if it is in the positive direction, it will go forward or with the same flight or to the cockpit, facing the cockpit rather. And if it is on the reverse side, it is opposing the cockpit but facing the tail of the aircraft. So uh, the key to um, the key to this type of propeller, or key to understanding this type of propeller, is that it this can help the aircraft reduce its speed when is going to touch down, and at the same time, reverse pitch propeller can also help the overall aircraft taxi on the ground because uh, since this is commonly found in big aircrafts or airplanes, uh, taxiing with taxiing the whole aircraft will be difficult. Therefore, reversing the pitch is also necessary for it to taxi on the ground in the airspace. Now, to continue, oops. Now we have the constant speed propeller. It is the propeller has a natural tendency to slow down as the aircraft climbs and the speed up and to speed up as the aircraft dives because the load on the engine varies. To provide an efficient propeller, the the speed is kept as constant as possible by using propeller governors to increase the or decrease propeller pitch. The engine speed is held constant when the aircraft goes into a climb. Uh, when the airplane goes into a dive, the blade angle increases sufficiently to prevent overspeeding, and with the same throttle setting, the power output remains unchanged. Well, it is pretty much self-explanatory, and that ends my part. Thank you.
To continue with the report, now we have feathering propellers, which must be used on multi-engine aircraft to reduce propeller drag to minimum under one or more engine failure conditions. Also, a feathering propeller is a constant speed propeller used on multi-engine aircraft that has a mechanism to change the pitch to an angle of approximately 90 degree. A propeller is usually feathered when the engine fails to develop power to turn the propeller. By rotating the propeller blade angle parallel to the line of the flight, the drag of the aircraft is greatly reduced, and the blades are held in feather by aerodynamic forces. Next, we are going to discuss the components. So first, first component we have is the air filter. So an air filter is a device that filters a particulate particles and other contaminants from the air. So as we can see in the picture, we have here the air filter. Then second is the intake manifold. So intake manifold is responsible for the even distribution of the air fuel mixture to each cylinder. So we can see in the picture, this is the intake manifold. Next, we have the carburetor. So a carburetor is a device that combines air and fuel for internal combustion engines and an optional air to fuel ratio for combustions. So this is the picture example of the carburetor. Next, we have the throttle body. The throttle body is a component of the intake system of fuel-injected engines that drive controls the accelerator. So this is the throttle body, and both carburetor and throttle body are part of the intake valve. So how does it work? So superchargers increase intake by compressing air above atmospheric pressure without creating a vacuum. This forces more air into the engine, providing a boost. With the additional air, more fuel can be added to the charge and the power of the engine is increased. So that is a mini background of the how superchargers work, and for you to have more an elaborate explanation and information, you can just click this link to view the details of it. So now let's proceed with the types of superchargers. So first is we have the centrifugal supercharger. So this is the picture of the centrifugal supercharger with the outlet side and the intake side. So specialized type of supercharger that makes use of centrifugal force in order to increase the manifold air pressure or MAP. So there are two types of centrifugal superchargers. These are automotive superchargers and aircraft superchargers. We have an additional video for the centrifugal supercharger and you can just watch it. Next, we have the root type supercharger. And third one is the twin screw supercharger. So these are supplemental videos that you can view in order for you to more watch it by yourself and understand it by yourself. And you can replay and forward it and backward the video for you to understand more about the components of the root type supercharger and twins screw supercharger. So let's have a basic overview of it. So that is an overview of the root type supercharger. Now we have the twin screw supercharger. So these are the parts of the twin screw supercharger. And you can watch it more by yourself to further understand the different parts of it. Now let's proceed. So what are the method of supercharging? So the method of supercharging, so the wastegate, the inlet portion of the turbine, and all other exhaust gas ducts present are all fully open when supercharging internal combustion engines, with turbochargers in the lowest load region as a naturally aspirated engine. So this load range is surpassed and the flow area of the turbine inlet is lowered to its minimum operating value and increase its maximum value at full load with subsequent increase in load. And the engine used in this technology features a various turbocharger with a throttle slide that controls the turbine inlet flow area as a function of the fuel injection quantity and boost pressure via an adjustment mechanism and a control pressure. So what are the different types of propeller accessories? So we have the following. So we have the blades, which converts power into thrust, and much of the design process and exercise in compromise between the competing factors of takeoff, climb performance, and cruise performance, noise, and ground clearance. And the result is that most modern propellers are highly efficient at converting power into thrust. Next, we have the hub assembly. So it is designed to contain the blades and the pitch change mechanism. So the steel hub design dates back to 1946, and this design utilizes both double and single shoulder blades. So the blades clamps are connected via linkage to the pitch change mechanism, which is externally visible. And this design was the mainstay of hard cell into the early 1960s when the aluminum hub assembly was developed. So Hartzell developed its aluminum hub or compact series of propellers to offer a lighter weight propeller for general aviation application. So the blades are rotated by a knob through a fork connected to a piston cylinder arrangement. And while it has evolved through the years, Hartzell has stayed with the basic design due to its proven durability. And next we have the spinner assembly. So a spinner assembly is used to cover the hub assembly and conform to the aircraft cowling. And this is the picture of spinner assembly. And that is all for today. And these are the references that we have used. So you can simply scan through this barcodes for you to read it by yourself and understand it by yourself and more elaborately um, get an info out of this sources that we have tackled. And that will be it for today. We hope that you have learned a lot from our presentation and thank you for listening. Have a great day ahead.